Hey everyone, welcome to the start of a new series. We are working through the Year 12 Standard 2 Investments and Loans topic here, and we're going to start by talking about something we've covered previously, which is compound interest, and through the lens of this course, we call this future value, so future value investments. Now, just to refresh your memory, the compound interest formula we dealt with in previous years was this one over here. So A equals P outside of 1 plus R to the power of N. We had our amount here. So our amount at the end of the investment once this matures. We had our principal here, the initial amount we invested. We had our rate, which was our interest rate. And finally, N, the number of years, or we talked about this more specifically as the number of compounding periods when we looked at different types of compounding periods, not just yearly. Now, when we deal with this in the context of future value, the formula actually doesn't change. The way you may see it written in your textbook is FV for future value equals PV, which means present value, and outside of 1 plus the rate still to the power of N. Okay, and we talked about this in previous topics, and I went through and really derived this particular formula up the top. So if you'd like to go back and really see how this works, please go back and watch that video. I'm just going to jump straight into it now. Now, as we can see as well here, this is an equation. So our future value equals our present value times this total thing on the right hand side, 1 plus R to the power of N. Now, we remember with any equations, we can rearrange these. So with this future value equation, with this FV future value as the subject of the equation, we can rearrange this to make the present value the subject of the equation. We can do this by remembering that to undo this multiplication to make PV the subject, we can just divide both sides by this 1 plus R to the power of N. And when I do that, I'm going to get on its own PV. Now I've just swapped the side that I've written it, but as we know with the equal sign, we can do this on any side we want. That's going to equal to our future value divided by 1 plus R to the power of N. So this is the main thing we're going to be working through here. So let's just jump straight into an example in which we're asked to calculate the future value. So let's say someone invests $7,000 over 5 years at 4.5% per annum. Okay, so we're trying to find the future value here. So we're going to first write out our future value formula. Let's try that again. So this is what we are trying to find. We're given a present value, we're given a rate, and we're given a number of compounding periods. Whoops, that's not meant to be an equal sign. This is PV times 1 plus R to the power of N. Okay, we're trying to find the future value. So our present value is the amount we presently have, how much we have at the moment. And that's $7,000. So I'm going to write that in here, 7,000 times. I have my rate, which is 4.5% per annum. I'm going to convert that to a decimal just because it's easier in the calculator. So I'm going to get 0.045. And I'm going to put in my number of compounding periods. That's to the power of 5. So right now, we're really just using this formula, practicing substituting in the relevant bits. And once we put that into our calculator and round, we're going to get 8,723.27. Okay, so the second question here, we're going to do something a little bit different. We want to calculate the present value of an investment, which has a future value of $500,000. And we're given a number of compounding periods of 8 years, and we have an interest rate of 8.5% per annum. Now, one thing I'm going to add for this question to make it a little bit trickier, this is compounded. Wow, that's shocking handwriting, apologies. Compounded monthly. So as you remember from before, this is going to, when we talked about this a couple of years ago, this is going to change my rate and number of compounding periods. Now, let's say I have 8 years here, but it's compounding monthly. So this is compounding 12 times, because there are 12 months in a year, per year. Now, for every 1 year, this is going to compound 12 times. So to find how many times it's going to compound altogether over the 8 years, our new n is going to be 8 times 12. And once I do that, that gives me 96. And similarly, our rate, we remember, is in per annum. So that means 8.5% every year, per year. That's what annum means. So there are 12 months in a year, so we can get the new rate by saying, well, there's 8.5% in 1 year, or in 12 months. What's the rate for 1 month? We're going to divide that by 12 this time. So going back to what we did when we dealt with this earlier, to find our new n, we're going to multiply my number of compounding periods by the 12, or if it's quarterly, by 4, anything. And to find our new rate, we are going to take our 0.085%, sorry, not percent, that's converted to a decimal, and divide that by 12. So we get our new rate now. And I'm just going to leave it like this. But we have here our new n and our new r. This happens when our compounding period changes. We've gone from annually to monthly. So our number of compounding periods change, our annual interest rate changes, depending on this level of compounding. Here it's monthly, you can get quarterly, biannually, even daily. So we're going to see how that changes it. Okay, so we're trying to find the present value this time. So I can just write this in the rearranged form I came up with earlier. Our present value equals our future value divided by 1 plus the rate to the power of n. And I'm going to put everything in here. So our future value is 500,000. And my rate, I'm going to put the new one, so 0.085 divided by 12. And my new n, I said, was 96. So I'm still just substituting it into the formula, but first when we approach these questions, we want to ask ourselves, is it going to change? And what tells us it changes is the compounding period. Is it monthly? Is it yearly? Like in the first question, this was compounded yearly, so we left everything. Once this period changes, we need to make our changes to our n and our r. So we write this into our differently arranged formula, and we end up with a present value. So what we had to put in at the start to get 500,000 was 253,916.41. And usually when we deal with money, we want to round these off into 2 decimal places. Now, let's talk about interest quickly, because what gets our present value to the future value is something called interest. This is what we accrue. So if we think of what happened here, we're calculating interest. What happened? I'm going to draw a little flow chart. So we had our present value, something we put in. After a certain amount of time, we gained interest. And from there, we got our future value. So we can get to our future value by taking our present value, adding interest to give us a future value. So we can then write interest. Our interest is going to be the difference between the future value and the present value. And we can find that by doing the future value minusing the present value here. Let's work through this with a couple of questions. Now, apologies, I have to rub this out from a previous video. And we will get through a couple of examples. So, with that in mind, now that we understand how our interest is going to work, if we try a question, let's say someone invests, let's do it in black. Let's say someone invests 10,000 over 10 years at a rate of 7.5%. Okay, first of all, there are going to be two parts here. First, we want to find the future value, and then we want to find the interest. Now, we said before, we get the future value by taking the present value, timesing it by 1 plus the rate to the power of the number of compounding periods. This first bit, quite simple. We are just doing the same thing as in the first example. We're substituting in my present value, we're substituting in our rate, because here this is compounded annually, so we don't have to change the rate, and we don't have to change the number of compounding periods. So this is going to give us approximately 10,000 times 1 plus 0.075. Whoops, sorry, I'm rewriting steps here. That's going to give us an answer of 20,610.32. Okay, so we found our future value, how much is there at the end, and we get to our future value remembering that my future value is my present value plus my interest. Now, like I said before, this is just a simple equation that we can rearrange. We get our future value by adding interest to our present value. Therefore, our interest is the difference between the future value and the present value. And I'm just going to write it in here as well. We can get this by subtracting the present value from both sides, just to show you that this works like a regular equation. So to find interest, we need to note what our future value was, and we found that just now, which is 20,610.32. And I'm going to subtract my present value, which from the question was 10,000. Okay, so that gives us 10,610.32.